Hey everyone, welcome back, and today let's solve Leetcode problem 2570 titled Merge two 2D arrays by summing values. So we're given two 2D integer arrays nums1 and nums2, and nums1 at any index I is equal to or is mapped to an ID at that index and a value sub I. And that indicates that the number with the ID sub I has a value that's equal to value sub I at that corresponding index I. Now nums2 or array 2 at any index I would also represent an ID and value at that index, and that would represent or indicate the number with the ID that has a value at that specific index in the second input array. Now each array consists, or rather contains, unique IDs and is sorted in ascending order by ID, basically meaning increasing order by the first value, or sorted by the first ID value of each list in the input array. Now we want to merge the two arrays into one array that is still sorted in ascending order by the idea, respecting these following two conditions. So only IDs that appear in at least one of the two arrays should be included in the resulting array, and each ID should be included only once, and its value should be the sum of the values of this ID in the two arrays. However, if the ID does not exist at all in either of the arrays, we have to then assume that it has a value of 0. And then we want to return that resulting array with these two properties or operations, and the returned array must be sorted again in ascending order by the first value, or basically by the ID value at each index of each list of the output. So in example 1, we have our input array nums to be 1, 2, 2, 3, 4, 5, and input array nums2 to be 1, 4, 3, 2, and 4, 1. Notice how it is sorted in ascending order for each ID in every single list of both the input arrays, and we have an output of length 4 of 1, 6, 2, 3, 3, 2, 4, 6. Notice how it's still completely ascended in order by the IDs, and we have all of these outputs to basically follow these two conditions, right? Where basically we only include each ID once, and its value should be the sum of the value of that specific index in both of the arrays, and it has, of course, a default value of 0 if it isn't in either one of these two input arrays. Now, why do we have an output of 1, 6, 2, 3, 3, 2, 4, 6? Well, let's go ahead and see why that is. At ID equals 1, or basically for the first or one value of an ID, the value would be 2 plus 4. Why is that? Well, in the input array nums, we see that there's one ID that has a value of 2, and there's also one ID that has a value of 1 in the input array nums2. So since we have two 1 IDs, or two IDs with a value of 1 in both the input arrays, we'll sum up their corresponding values, which would be this 2 mapped to this 1, plus this 4 mapped to this one in the second input array. And 4 plus 2 is 6, and so 6 would go in place of the ID 1 in the output array, right? Now, for ID equals 2, that would be an ID value of 3. Why is that? Well, because it's in the input array nums in the first one, so we'd have a 3 being mapped as a value of the ID 2, but it isn't in input array nums 2. For ID equals 3, notice how that still is in the input array nums2, although it isn't in the input array nums1, and it does have a value of 2, and so its corresponding value is just 2. And finally, for ID 4, it's actually in both of the input arrays. One of them is 5 in the first one, and its other value is 1 in the second one, and 5 plus 1 is indeed 6, and that's why we have these outputs. Notice how all of these IDs are in both of the input array nums, and their sum is basically the sum of the values in each corresponding individual input array nums summed together, exactly how the problem statement tells us it's supposed to be like. In example 2, applying very similar logic, we have our input array nums1 to be 2, 4, 3, 6, 5, 5, and input array nums2 to be 1, 3, 4, 3, and in this case we have 5 as such common IDs with summed values, right? 1, 3, 2, 4, 3, 6, 4, 3, and 5, 5. But there is also something very important to note about this specific example. When I say common IDs, we only want the IDs that are in at least one of these input arrays. Now notice how none of the IDs, not a single one, is in both of the input arrays. And so their values, of course, are not going to be changed because we're not going to be subbing anything up, or we're not going to be subbing any values for any of the IDs because they're all individually in only one of the arrays. And so since there are no actual common IDs between both the input arrays, we simply have to include each ID by itself with its individual value of its corresponding input array and our resulting list output. And as you can see, that is really just a combination of these IDs in one array, right? So for the constraints here, we see that the length of our input array nums1 and nums2 are both not going to exceed 200, and any value or list at any index in both of the arrays is always going to be 2. We're guaranteed to have only an ID and a corresponding value mapping and nothing else, no invalid inputs as such according to the problem statement, and any ID and value of every single list in both input arrays are never going to exceed 1,000. Both arrays are guaranteed to contain unique IDs, and both arrays are also guaranteed to be strictly in ascending order by the ID value, kind of guaranteeing us exactly what the problem statement told us, and we don't have to worry about any weird special edge cases or invalid inputs for the context of this problem. And that brings us to what solution can we kind of make to really solve this problem in the most efficient way and algorithm possible. Well, that is, we know for a fact that both arrays are already sorted by their index or ID values, and since that's true, we can actually efficiently merge them using something called the two-pointer technique or two-pointer algorithm, right? It's very similar to a problem merging two sorted arrays. I don't exactly remember the problem statement of it, but it's very similar to that. Effectively, the way that works, we're going to use two pointers. We're going to use a pointer I and a pointer j. I is going to be for array 1, and j is going to be mapping or for array 2 to iterate over them respectively, right? And effectively, at each index I and j, we have to compare the indices at array 1 at index I and array 2 at index j, right? Because, again, I is for array 1 and j is for array 2. Now, if at the current iteration or at the current conditional, if both of those indices are equal, if both of those IDs are equal, we have to then sum the values and basically just move the both pointers forward, right? Simply just going one step further in each index if the both IDs or values are equal. However, what if one ID or index is smaller? If that's the case, we have to first append that element to the result and then move its pointer in that specific corresponding array accordingly. And then we have to continue doing this until both of the arrays are completely traversed and we've got all of the common IDs, right? And of course, we're going to store that merged result in a list, and that's going to be that list that we effectively output as our final answer. So let's go ahead and get into the code here. So like I just talked about, we're going to be using two pointers I and j for the first and second input array respectively. So I'm going to initialize those two variables to both be initialized to 0. Why? Because of course we have to start from the 0th index or the 0th value or ID in both of the arrays before actually iterating through them, right? These are kind of our two pointers, and we also have to get our result. This is going to be that merged resulting list. This is what we're going to return. It's going to be that merged data or that merged list, right, by summing the values that are correspondingly common in both of the 2D arrays, right? So now let's actually iterate through both of the arrays. Now, we're not going to traditionally use a simple for loop here like we usually do. Why? Because we actually have two different input arrays. We have two different pointers, and so to actually iterate through both of the arrays in one loop, we're going to be using a while loop. So this while loop is going to check while our two pointers are actually in bounds. So while I is strictly less than the length of array 1 because that's its mapping, and j is for the second array, so while that's less than the length of the array at 2, while both of these pointers are at valid indices, we don't go out of bounds. So basically, until we actually reach the end of one of the arrays, we have to actually compare the indices at the specific index for I and j and compare the values and merge them if needed. And how do we know if we have to actually merge the values? Well, if the ID value or if the value at the specific ID of the current two indices, if they're equal. And so we can very simply check that if array 1 at index I at index 0. What is index 0 going to tell us? It's going to tell us the ID value for the specific index I. Why? Because we're guaranteed that each index I is going to be the ID first, and then the value, the 0th element or the initial element in this list of length 2 at any index I is going to be the ID. And so we're going to be comparing the 0th index or the ID value of each list at each index I when comparing if we have to actually sum up the values or not, because that's what we have to do for equal IDs. So if this is currently equal to array 2 at j at 0, of course, because that's the ID value of the specific index j in the second input array, if that's the case, we have to actually merge the values. And so very straightforwardly, we're going to append to our result, and I'm going to do this a little bit weird, like syntax-wise, but it shouldn't be too difficult to grasp, I hope. It's going to be array 1 at index I at index 0. Again, index I at index 0, all that does is really just give us the ID value of the current index I, and we're also going to append array 1 at index I at index 1 plus array 2 at j at index 1. Index 1 is going to give us the mapping or the value of these two specific equal IDs, and so that's what we want to actually output to the result, right? Basically, again, if that's the case, we have to actually append that specific value to the result, kind of merging their sums or simulating, merging the values of the two equal indices or IDs and increment our 2 pointers forward. Basically, kind of simulating moving forward one step further, or moving both the pointers forward in both of the arrays, because both of the arrays at this specific index ij actually do have equal IDs. What are we doing on line 7? To kind of reiterate, basically, if the current indices are equal or the IDs are equal, we have to actually sum up their corresponding values from both of the respective arrays and then append the index and the summed value to the result. Right, and I'm just going to quickly make sure that I haven't made any syntax errors here. I do not think I have, and so we should be able to move on to the next line of code here. So, while that's the case, if the current two indices are equal or the IDs are equal, perfect. Now, what if that's not the case? Meaning, what if we don't actually have two equal indices in the input array? What do we have to do then? Right? That's a great question. And we can simply really check that using an elif conditional. So, else if, or elif in Python, array at index I at index 0. If that's less than array 2 at index j at index 0, we know we have to move the I pointer forward. So we'll first append the result, or result.append array 1 at index I. That's going to be the smaller of the two indices, and then increment the I value forward, basically moving the I value for the first array forward because it still is, or it still has a smaller ID value than the current index j and the second array. And so we have to kind of keep moving forward until we as such catch up with the ID value of the current j value in the current second input array. However, in the else conditional, if that's not true, this basically means that the current j index is less than the I index. The I index is greater, and so if that's the case, we want to then move forward to kind of catch up ID values in the second array. So we'll first append result.append the current ID value, or just value array 2 at j. That's basically the current pointer that we're at in the second array, and then we have to move j forward, basically simulating going forward in the second array if the current ID value of the second array is smaller than the first. Now that covers our initial while loop here. Now let's move on to the second while loop, or the second iteration of the remaining elements from array 1 and array 2. So we're going to have another while loop here. So while I is less than the length of the array 1. What if we haven't appended some number of elements, if any, that we still have to do or append to the result? If that's the case, well, we still have those elements remaining, so while I is still in bounds, starting from whatever value it's currently at, we'll append to our result.append array 2, or rather array 1 at index I. Array 1, or rather, I should say array 1 at index I. And then we'll then move I forward, basically simulating that we've added this current element or ID, and we want to move one index forward while we're still in bounds. And very similarly, we'll do the same thing for the second input array. So while the j is less than the length of the array 2, while we still have elements to add, if any, we'll keep adding them. So result.append array 2 at index j, and then simulate moving forward. So j plus equals 1 while we're still in bounds. And effectively, once all of this is done outputting, we simply want to return our final merged array, which would be stored in the result. And to kind of reiterate what we're doing here, basically, if array 1 or array 2 still has elements left that we haven't appended yet, we have to actually append them to the result, effectively simulating appending the remaining elements that we haven't added yet from both of the input arrays 1 and 2. And effectively returning that final merged array as our output, which is going to be stored in the list result. So unless I made any syntax errors here, this should be accepted and there should be a valid solution. So let's go ahead and double check that. Okay, yeah, probably a very simple syntax error on my part. So let's see what I did wrong here. Elif, want to append array 1. Okay, let's see. Oh, oops, so it looks like I added a colon for absolutely no reason. Yeah, sorry about that, guys. I probably did make another very simple syntax error here. Let's go ahead and double check. Yep. Yeah, there should be array 1, not array 2, not array, just regularly. Sorry about that, guys. Let's go ahead and check if it works now. Feel free to just fast forward this part, guys. It's just me debugging my really simple syntax errors. But as you can see, this is actually an accepted solution, and it is just about as efficient as you can get it to be. So on a high-level rundown, how does this code actually work? Basically, we have 3 different while loops here, or 3 different passes. First, we go over all of the elements while we're still in bounds of both of the input arrays and add correspondingly in still ascending order according to both the pointers I and j, the smaller of the current values I and j of the current ID values in the both input arrays. However, if one is smaller, we have to add that as the smaller current ascending, or rather smaller current ID value and move forward, keeping that ascending order in check. However, if both of the ID values are equal, we want to add their merged value and move on one index each in both of the arrays. Why did we go in both of the arrays? Why do we increment the indices for both of the arrays or the pointers for both of the arrays? Because we're adding elements for both of the arrays only if both of the elements at those specific indices, I and j, of the first and second arrays, if they're actually equal, right? And these last two while loops here are basically just to cover all the remaining non-appended elements that we didn't append in the first pass or first iteration of the solution, and so that's just the entirety of why the second and third while loops exist, and effectively we return our final merged output. Right? So for the runtime complexity here, this is actually going to be a big O of n plus m solution. N is going to be the length of array 1, and m is going to be the length of array 2. Why is that? Well, because we really just iterate over both of the arrays exactly once, and so that would be the overall time complexity, right? We're processing each element in each array exactly once with the while loops here. And for the memory or space complexity, it is also a big O of n plus m. Why? Because we literally have one exact, we literally use one piece of auxiliary memory, one extra data structure. It's going to be that merge result, and we're guaranteed that that merge result is going to be in the new list. It is going to be exactly both of the elements from both of the input arrays stored or merged together, and it's going to be around big O of n plus m, right? That's why it's going to be that for the space complexity or the memory complexity. So if you guys enjoyed the solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.